Yes, yes, I already put on recording. Okay. So now, so again, the difference between non-renewable and renewable means you cannot use them again. They are in a limited quantity. Renewable, you can use them again and again, and they can take million years to produce, and here they can short time to produce. The example, fossil fuels like coal, oil, natural gas, and nuclear power like uranium, they are all fossil fuels because once you use them, you cannot use again. But other geothermal, hydroelectric, tidal, wave, wind, solar power, biofuels like bioethanol, biogas, and wood, they are all renewable. You can use them again and again. So this is the main difference between them. I hope everybody got it. Can we move further?
Yes.
Okay. Now we will see here. Just 1 minute. Whenever you will want to produce electricity, so all the method, whatever the method you will use to produce electricity except solar system, you need a turbine and you need a generator. In physics, electricity, you saw the AC generator, and AC generator, you know that the coil moves between two magnets and it produces electricity. So you need a turbine and you need a generator to produce electricity with the help of the process known as electromagnetic induction. Now let's see how the turbine look like. The turbine is really simple thing. It's like a fan wings, you can say, but it's quite big. So this turbine rotates. They are rotating this turbine. When this turbine rotates, they can rotate it with the help of wind. They can rotate it with the help of steam. So they can rotate it with the help of water. When high pressure wind, high pressure steam, high moving water falls on this turbine, they move like a fan. And you can see their shafts, these ones. They are fitted with generator, and generator produce electricity. This one, if you took in physics, maybe you are not electricity, so inshallah you will study that one there. So this is the main function. As I told you, if you want to produce electricity except solar, you need a turbine and you need a generator. Understand? How they will use it? See here now. They are using this turbine now. If you see this turbine, here the high pressure steam is coming. See here. And when high pressure steam comes, this turbine rotates. When this rotates, it is fitted with the generator here. I will show you that one also. So then generator moves. Inside the generator, you have a coil. And that coil moves, produce electricity. So this turbine you can move with the help of water, with the help of steam, with the help of wind. Now see this one here. Aware of this one or not?
Yes.
Okay. Here, this is the coil, and this is your slip rings, and this is the brush, and this is the electricity. So when this coil rotates and electromagnetic flux is changed, at that time electricity is produced. So it means this is the generator part. So if you fit this coil with turbine, if I put a turbine here with this one, here turbine. So when steam comes, this turbine moves and this coil start to move and electricity start to produce. Here I can use steam, here I can use wind, here I can use water, this one here, to move the turbine. And turbine will move the generator and electricity is produced. Is easy or difficult?
Easy.
Easy. Okay, now see here. This is they already fit, this is the turbine part, and this is the generator part. So they already fit a turbine with a generator. If the strong wind will come here, or the water will come here, or high pressure steam come here, it start to rotate, and it is fitted with the generator, and electricity start to produce. Here, for example, windmill, the wind, these wings, they move due to the wind, and here they have generator, and then generator produce electricity. So this is the main function how electricity is produced. If the meeting will finish, so please go back to the same link and join again, which I sent in this one. So here again, they describe in a more simple way. This is the turbine. Here steam is coming, water is coming, wind is coming, this rotating, and it is fitted with the generator. This is the generator, and electricity produced, which goes to the grid station and then your houses. Any confusion till here?
No.
Okay. Now, the fossil fuels and biofuels, you should know the difference between them. Fossil fuels means the fuel which are produced from the fossils, like coal, like gasoline, like diesel, like natural gas. But biofuels means you will produce them from plants, like vegetable oil, and sometimes you're using by animal waste. Like in bio, maybe use that waste of animals they use to make a gas. That gas is known as biogas. So these are biofuels. And alcohol. You know, alcohol, you can produce alcohol from sugar. And any fruit which has a sugar, you can convert into ethanol. For example, the grapes, you can convert them into alcohol. Sugar cane, you can convert them into alcohol. So alcohol is produced, and this alcohol is used as a fuel. In some countries, instead of petrol, the cars are working on ethanol. So that is known as biofuel. Any confusion till here? The difference between fossil fuels and biofuels?
No.
Okay. Now see here. There is one more comparison we can do between them. Number one, that biofuels renewable, fossil fuels non-renewable. Source, they are coming from plants and recently produced from organic waste, which is coming from the animals. Even the waste you are throwing, the trash from your house, also using to convert into biofuel. Organisms that have been died millions ago, it's produced by that way. Impact on health, the fuel which is produced due to plants and animals like biofuels, they are non-toxic, they are not release any harm gases, but here they are toxic, I mean cause a lot of pollution. State of industry right now growing, the biofuel industry is growing. Even you know that now the Tesla and other companies, they produce electric cars, and the people are saying that maybe up to 2030 the 70% cars will be replaced to electric cars, or maybe more than that. So now there's a lot of potential in this industry, biofuel industry. And here fossil fuels, even Saudi Arabia, they are decreasing the dependence on the fossil fuels. They want to go for renewable sources. Any confusion in this?
No.
Okay. Now, in how you can get nuclear power station used to produce electricity. You know that uranium is a radioactive element. So when you do the nuclear fission, there are two types of, one is nuclear fission and other is nuclear fusion. Can anyone tell me the difference between them? No? Okay, I will tell. Fission. Fission means a big nuclei will break down into smaller nuclei. It can be two or more than two. It is a big nucleus, it will break down into smaller. At that time, when it breaks down, it releases a lot of energy. And that energy is used to heat the things or the other sources. And okay, anyone is left? I think one more. Ola, any question? Mesam, Lean, and
No.
Radad.
Oh, no.
If you have anything, ask. Okay. So can we start?
Yes, sir.
Okay. So I was telling you about the difference between nuclear fission and nuclear fusion. So in nuclear fission, a big nuclei will break down into two small nucleus, and during this process, a lot of energy is released in a form of heat. And that heat can be used for different purposes. If you can control that heat, it is used in a nuclear power station to produce electricity. And if you cannot control that heat, it is uncontrollable, so then it is used in nuclear bomb as a weapon, which in Japan, remember, America dropped to in Hiroshima and Nagasaki too. That is uncontrolled. And in the nuclear power station, it is controlled. Whatever heat you need, you can control that one. This is what happens in nuclear power station. In nuclear power station, when you have a uranium, and that uranium will break down, and in radioactivity in physics, so you will study how the nuclear fission happens. So but right now you can see here that this is only the uranium is used, that due to nuclear fission the heat is produced, and that heat is used to heat the water, and that water is heated, and then it convert into steam, you can see here. And that steam with high pressure, it goes to the turbine and it moves the turbine. This turbine fitted with the generator, and inside the generator you have a coil, and when that coil moves, electricity is produced. Once again, the heat which comes from the uranium that is used to heat the water. When you heat the water, water will convert into steam. That steam will go here and it is collected here. When steam become high pressure, so they will bring the steam here on the turbine and it pass through the turbine. And when something moving with a high pressure, the turbine start to rotate. And as it rotates, it fitted with the generator, and generator, inside generator, you have a coil which moves and produce electricity. Any confusion?
Can you re-explain the fusion?
Fusion means that when two small nuclei, they combine together to make a big nucleus, like it happens in sun. In sun, hydrogen atoms, they combine together to form helium. And it also produces the lot of heat. Due to that, sun is producing heat. So that is fusion. Inside the sun, it is fusion. Understand?
Sorry, it combined together to
Yes.
form what?
Now here in fusion, two small atoms, they combine together to make a big new atom, or in other words, two small nucleus, they combine together to make a big nucleus. Hydrogen nucleus is smaller as compared to the helium. So two hydrogen, they combine together to produce helium nucleus.
It means when two nuclei combine together to form a nuclear.
Sorry, say again.
When two nuclei combine together to form a nuclear, yes?
One big one. So that is fusion. Even from the name, you can say fused, to when you combine two things. Okay, that word. And move further. Okay, geothermal. It's also very interesting. Now, they're saying that geothermal. From the name, what comes to your mind? What does it mean? Geo mean what?
From the earth.
Geo mean earth. Good. And thermal mean heat. It means heat comes from the earth. There are some areas in the world where under the earth, maybe up to some 100 meters, you will find hot rocks. You will find hot rocks. And these hot rocks, sometimes even they're also known as hot springs. In some countries, they're coming out of the ground. So these hot rocks, they are found not everywhere, in some areas. You can see in this picture. Here you have these hot rocks down. And how they will use this energy from the earth, the heat of the earth, to convert into electricity. Really simple. What they will do, I will explain to you now. See here now. I will just enlarge it for you so you can see it clearly. Okay. Now, for example, here you have the hot rocks. This is the place where you have hot rocks. They will drill a pipe down here. And they will drill another pipe here. Okay. Now, from here, cold water come, injection well, means from here, cold or normal water. It will come down. When this water will come on the hot rocks, it will become superheated because hot rocks have very high temperature. So when this cold water become hot, it convert into steam, and that steam will go up here in number 2 here. Then this steam with high pressure, it will fall on the turbine, and the turbine start to rotate. And the turbine start to rotate, it is fitted with the generator coil start to rotate, produce electricity, which can supplies to the homes and the industries. Any confusion?
Excuse me, sir. I said to you that my connection is bad, so sometimes I didn't hear.
No, I'm recording it. I'm recording it, and I will send it to you. Don't worry.
Okay, so can you just explain it, because I did not hear anything.
Okay. I'm saying that in this process, they have to make 2 pipes. One is here and one is here. In this pipe, they will put normal water. From up normal water, they will put it down. When this water comes down, here you have hot rocks. And the water, when come to the hot rocks, it will become superheated. You know the meaning of superheated? The water which has temperature more than 100 degrees. And then it convert into steam. When it convert into steam, that
So the hot
steam,
rocks convert.
because no, not hot water, the rocks will just heat the water. The rocks will just use to heat the water. Rocks will not convert into anything. Their heat is used to boil the water only. And that water, when becomes steam, it comes up. And that steam go to the turbine. Turbine start to rotate. It is fitted with a generator. So generators start to produce electricity that can be supplied to the homes and the industry. Is it okay? Can we move forward now?
Yes.
Okay. Now wind power. Wind power, it is again, it's quite simple. That energy from the wind, it is used to produce electricity. These are the windmills. They are known as windmills or wind turbines. Both words are used. Wind turbines, and sometimes you will use windmills. Okay. So here wind comes on these big, this one, and they move. And when they move in this box, they have the generator which start to move and produce electricity. So, but again, they are used only the areas where you have the wind, strong winds 24 hours. Every part of the world is not suitable for them. We will see also this one. Okay. And how they will produce electricity, let's see in more detail here. See here, this box. Now, these are the rotating blades, big ones. When the winds come and strike on these blades, they start to rotate. You feel that their rotation is very slow, but this rotation is increased by using a gearbox. Gearbox is a machine which will increase the rotation. You know the cycles, the bicycle used for, which has the gears, and by applying a small force, they move really fast. The function of a gearbox to increase your force. This question will not come in the exam. What is gearbox? I'm just explaining to you because you are physics and chemistry students. So the gearbox, it will increase the, you can say, rotation. And when this rotation will come to the generator, it is very high speed. And generators start to rotate and start to produce electricity. And that electricity can be produced, can be transferred to the cities and the other areas. Any confusion?
No.
Okay. Now solar panels. Now solar panels, it is quite, you can say, in now. There are a lot of people are using this one. In solar panels, now here solar energy is used. So that one I'm talking about, remember in the beginning, here you're not using any turbine, you're not using any generator. You are using special cells. They are known as solar cells. They are made by a special material. Mainly they are made by silicon. It is an element in your periodic table. Silicon is a metal and non-metal. Can you tell me?
Non-metal.
No. Both are wrong. They are metalloids. They are semi-metals. In chemistry, you have this one, semi-metals. They are metalloid, mean element which has properties of metals as well as non-metals. Silicon, germanium, they are also sorry, non-metal, semi-metals. So they are mainly made by silicon. And when the light fall on these solar plates, so they will convert into electricity. Okay, so how I can explain to you now here down, see here. So here you have the sunlight it is falling on this solar panel. So when you are arranging like this, so it is known as solar panel. Solar panel means it has a lot of solar cells here. Then if you see this diagram, photons mean these light, I think in physics, not in your IGCSE, in A levels, it is there. Light travel in the small packets. Each packet is known as photon. Anyhow, when the light fall on these ones, so the electrons are produced and electrons start to flow. And when electron flow, the flow of electron is known as electricity. So it works like this. In the exam, they will not ask this one in environmental, but as a physics student, I'm just telling you this one. So simply, the sunlight falls on the solar panels, and solar panels, they convert sunlight into electricity, and that electricity is used for homes and for other purposes. Any confusion?
No.
No.
Thanks.
Sorry. Now you have tidal power. Tidal power, from the name, you can say from the tides which are produced in other word, you can say the waves, in simple word, waves which are produced inside the sea, they can be used to produce electricity. So you can see this diagram, sometimes the same structure like windmills, it is inside the sea, and the water comes, they rotates, and then electricity is produced by the same way. This is one method. Sometimes the tides in the, okay, if you observe the sea, at which time the tides are high, in the daytime or in the night time?
No, night time.
Night time. Even if you go to the sea in the day, you find the water will leave the beach, it will go away from the beach, but as the night comes, it again comes on that place. So what they are doing, they are making the small areas near the sea, and this is like a big holes. When the sea level increase, so the water comes and store inside them, and when the day it is full, so in the night when it is full, they close the gate. This is happening in night. And water, because water level is become high in the sea, it comes here and they store this water. In the day, the water level decrease and up come till here. At that time, they open this door from here. They open this door, water comes back towards the sea, and they fit a turbine and generator here. When this water moves through the turbine moves and generators start to produce electricity, and that electricity can be used for different purposes. Any confusion?
Can you explain the last point?
So, okay. I'm saying that in the day, when the sea tides are low, so then no use. In the night, when the tides become very high, so they come and water will come and store here. They have a gate here. And when the water comes here, it is full, they will close this gate. Okay. When the gate is closed, then in the day, in the night, the water remains still here. If you open this gate in the night, water cannot go back because level here and level here same. In the day, this level went down till here. Then you open this gate. When you open this gate, the water falls from here towards this part, because this is the only path from water can pass and go to the sea back. So here they fit a turbine. When the water passes through this turbine, it rotates and it is fitted with the generator and electricity is produced. So again, next night, again they fill it with water. Again in the day, they leave it. This is like a repeating process. Any confusion? Okay, the same diagrams here, the same which I explained to you. Here, high level, let's go to this turbine, again going back to the ocean. But these again in some countries which has the sea and they have this high tide, they can use it. The wave power. Maybe sometime you saw this type of things inside the sea. So they are used to produce electricity. So these are, you can say here, when the waves move up and down, these objects also move up and down. When they move up and down, so they have a system inside, they produce electricity. Okay, how? Let me explain to you. See here, this one. Now, for example, here, when this is the system which is inside the sea, when the water levels go up and down, so here water go up, sometimes go down. So this movement create a circular movement. Moving up and down in a closed container move circular movement, and that circular movement is move turbine, and turbine move generator. Once again, I'm telling you, they will not ask the mechanism that each and everything. Maybe they can give you this above diagram, which is here, and you can ask. But you should know, because these things will come physics in physics also. And here they can ask. So that I'm explaining this one. Okay, next. Again, same thing. Sometimes you'll find like this. This type of objects in the sea. They have down like this. Again, water move them up and down, and up and down produce a movement in a generator, and turbine, they move and electricity produce. They are known as bios, this one. And EMF mean electricity, electromotive force. So this is produced. Any confusion?
Sir, question?
Sorry.
Yes, ask.
So, for example, if someone like is swimming in this area, then he touched the below tower, like he electric shock or not?
First of all, these areas, whenever they are using it, they already marked outside. They will put the red flags or something that people are prohibited to go there. But secondly, even they are going there, so it is not earthed. You cannot get electric shock, because if there is electricity, it can make all water electrical, and even the people, they are highly insulated. This is just like a movement, and that movement is going to a turbine, and generator is producing electricity, and from there the wires, they are highly insulated, they cannot go. I mean, electricity cannot get electric shock. But due to the movement of this up and down, maybe you get hurt, but you cannot get electric shock here. Understand? Hello.
Yes.
Okay. Now this is hydroelectric. Hydroelectric is used by a lot of countries. So what they are doing, they are making dam. Dam is a place where they store water. This is the dam. All dam, this one. Here they store the water. And dam all mostly on the high places where you have mountains, and the water comes up from the mountain and it stored here. Then they will make from here they will make the doors, and each door down they fitted a turbine. When water comes with a high speed down, it fall on a turbine. When water falls on a turbine, turbine rotates. When turbine rotates, it is fitted with a generator, and generator start to rotate and electricity is produced. So this is known as hydroelectric. Hydro means water, and electricity produced by water. So that's known as hydroelectricity also. So these dams, again, some countries, they have this type of locations where they can produce, they make the dams, not every country. Okay. In your Sudan, we also have the dam like Marvi Dam and all these things. In Saudi Arabia, there's no dam. There's no place where they can produce. Maybe in mountains they have little bit, but they cannot produce that much of electricity. Understand now what is a dam? Dam is a place and where they store the water, and it is on a high place. Then they drop the water. Sometimes they drop the water through a pipe. A pipe comes from there. And when the water comes through a pipe down maybe 500 meters, it will get a great kinetic energy. And then when it falls on the turbine rotates, and the turbine fitted with generator and produce electricity. Any question regarding this? You can see this one here. Here, this is the dam. Water comes with a high flow here. And this is a turbine. Turbine rotates. It is fitted with a generator, and generator is producing electricity. Any confusion? Okay. Now here we will see the advantages and disadvantages. Whatever the sources of energy we discuss now, in which we have wind energy, we have geothermal energy, we have nuclear power stations, hydroelectric, we will see the advantages and disadvantages also. Please pay attention because it is also important for you in physics. The same thing is replicable there. Now, if you're using the fossil fuels, it has some advantages. Number one, plentiful supply means you have a lot of supply. Plentiful, a lot of amount. Like coal, you have a lot. You have oil, a lot. I'm talking about as a whole generally. I'm not specifying one country. I'm talking about on earth. You have a lot. Provides job opportunities, mining and processing. For example, if you want to use the fossil fuels, you have to take it from the ground. And for that, you need the people. It means fossil fuels create a lot of jobs for the people. Number three, the technology used in a well-known method of extraction, well practiced, because people are taking this maybe more than 100 years, so they know how to take it. So now it is easy to take out. Disadvantages of fossil fuels: produce carbon dioxide and toxic gases. Okay. And number two, damages local area, because sometimes if there are a lot of factories in some area, or the city has a lot of traffic, so that whole you can say air is polluted. Then after that, limited supply as a in terms of non-renewable means whatever the quantity you have now, but if you use it, one day it will finish. It's non-renewable. So these are advantages and disadvantages of fossil fuels. Any confusion?
No.
Yes, sir.
Yes, ask.
Sir, the advantage. The first point, plentiful supply, and in the disadvantage, limited supply. Sir, how? Because they said that there is a lot of supply, but then the advantage, there is limited.
Yes. Yeah, very good question. Plenty of supply means, for example, if you are using, let's say, another source, like you are using hydroelectric.
You can hear me?
Yes, I can hear you. Now, can you mute your mic? I can explain to you because there is some background noise. So when you have using another method like hydroelectric we use that now, you have to need a dam. In the dam, water is stored. How much water will come here? It depends on some factors. Number one, rain factor. Number two, snow factor, like this. So here you are dependent. The supply is not constant. Even you are using solar cells. If you have clouds, if day is cloudy, you cannot get the supply. It means here the supply is depending on some factors. You cannot guarantee the supply 100% every time. Here, plentiful supply means that if you have a source, if you have, for example, crude oil under the ground, You can take it anytime, even the daytime, even the nighttime, even it is raining, even it is cloudy. So supply is continuous. But here supply is limited. Means if there is no rain, no snow, water level goes down. Maybe you have to stop the producing generators to produce electricity. Maybe there is no sunlight. The supply is finished. So I'm talking about this contact, supply contact. Supply means you here something is needed, and here from here you bring. So how the thing will come from here to here, that is supply chain. Got it now?
Sir, can you repeat it?
I'm saying that supply means that something will comes. For example, here you have a power station, and this power station working on fossil fuels. Now you have fossil fuels here like crude oil. So you can bring this supply here with the help of pipeline, with the help of truck. Whatever you have, you can supply it to power station. Weather cannot affect it, other conditions cannot affect it. But if you have non-renewable, like you have renewable, like solar, renewable, solar. If now you have a solar cell here, you need the solar sunlight on solar panel to produce electricity. But if the clouds comes, your supply is limited. Maybe no supply, finish. Now you cannot produce electricity. You have windmills you have. If there is no wind, you cannot produce electricity. No supply. Supply means something is not available. You have every setup, but it depends on wind. If no wind, you cannot produce electricity. But fossil fuels, you can take up from the ground and you can use them anytime. Their supply is not limited. I'm talking about this one. Don't think there is a difference between amount and supply. Amount means how much quantity you have. Supply means you are moving the things from one place to another place. That is supply, not quantity. Maybe you are mixing these two things. Understand now?
Yes, sir. So I mean, for the plentiful, if I have the power or I have the supply, I will take it to the station. Yes.
For example, if you have a crude oil, at any time you can take it. In the day, in the night, you don't need the sunshine, you don't need the wind, you don't need anything. This supply is all the time available. But others, they are not available. Like hydroelectric, if you have water, you can produce electricity. Solar, if you have sunshine, you can produce electricity. Windmill, if you have a wind, you can produce electricity. There you have dependent. Supply is not reliable. Understand? Hello? Is it okay?
Yes.
Okay. After that, again, the biofuels. As I told you, the biofuels which are produced from plants. And here, okay, one word is missing, supply. Why? Okay. Renewable resources mean you can use them again and again. If you are producing something from trees and fruits, you can plant the trees again and you can produce the fruit again. If you are producing something from the waste, so that waste all again available, like this. Again, plentiful supply all the time. You can say that you have a supply there, but once again, that this biofuel, once you prepared them, it's available. Again, don't be confused that Mr. Munawar said that here, renew plentiful before, then here's no. Here means that if you prepare something, for example, you are preparing something from fruits, like you're producing alcohol, let's say. Once you prepared it, you can use it anytime. That talking about. Disadvantages. Carbon dioxide and toxic gases are released when burned. Yes, sometimes they also produce carbon dioxide. Lot of land needed. If you want to cultivate trees and other things, yes, you need the land. Shortage of land for agriculture. For example, if you go for this one, so then maybe the land will be less for the producing the food for the people. And sometimes you have to you are disturbing the natural ecosystem. So these conditions sometimes all are applicable, and some places sometimes one of them is applicable, because if you are using animal waste, I give you the example now. Animal waste, if you burn it, carbon dioxide is produced. If you are taking alcohol, you burn it, carbon dioxide is not produced. So both are biofuels. So sometimes one of the biofuel creates the issues, other is not. So don't be confused in this one. Can I move forward?
Yes.
Okay. After that, you have nuclear power. This is also when you use uranium. Advantages: does not produce carbon dioxide. Yes, no emission. Large amount of energy is produced with a small amount of fuel. Yes, a small amount of uranium, if you will use it, you can produce a large amount of heat. Job opportunities also produce. But there is a disadvantages: high risk of radiation. If radiation comes out, it can disturb the everything, especially the people. And maybe you saw that the people who are working in nuclear power station, they are wearing the special type of clothes. They will stop the radiation. Radioactive waste cannot be recycled. It's very, you can say, the bad thing. For example, if you use any element, for example, this is uranium. You put in a power station, you got the heat from it. After that, the waste will come. And that waste, you cannot get energy from that. So that is waste for you. But this waste produce radiation, alpha, beta, gamma, and that they are really dangerous for the people. So when the waste come out from a power station, they have to put in special containers. That containers mainly they made by lead, because lead do not allow the radiation to go out. After putting in the lead, they have to store it at some place where it will be undisturbed. And some of time it needs 5,000 years to become neutralized. So this is really long time. Understand? Any confusion?
No.
Again, that geothermal, in geothermal, they said that you have the advantages: does not produce carbon dioxide, and limited supply, unlimited supply. If the rocks are down, you can get renewable. Unlimited means renewable here. Disadvantages: expensive to install.
Excuse me, sir. Excuse me.
Yes.
Another name for plenty for supply is unlimited supply.
Yeah, plenty, you can say unlimited. Plenty actually means a lot, uncounted. But here you cannot say unlimited means for the like others. They are comparing with others as compared to them, because hot rocks always they have a high temperature, so they can use it again and again and again. So in that term, they are taking it as a renewable.
Excuse me, sir.
Yes, yes.
It means for the unlimited supply. For the fossil fuels, it means for some substances they're limited and some unlimited. Yes.
The fossil fuels, all fossil fuels, they in quantity they are limited. Okay, so you have two things, renewable and you have non-renewable. Fossil fuels comes in this as we discussed. In all others, now we're discussing geothermal, is comes here. When you're talking about here, unlimited supply means here that they are renewable. You can use it again and again. Fossil fuels, they have a means quantity, which is because in